Hello student, welcome back to lecture series on statistics. Hey guys, in my today's video I'm gonna explain to you all one of the important question which is from SPPU question paper based on the topic of regression. Okay, regression. Already I explained plenty of the examples and another topic like a correlation and the skewness, momentous. Okay, so if you are interested to see these videos guys, go and check here in I button, or you can see in my description box. You will get the entire playlist. Okay, so without further ado, let's get dive into our today's lecture. So in our today's lecture we have question based on regression. Okay, so this one is the question repeated mostly in your SPPU question paper for 5 marks. Okay, May 6, December 11, December 15, December 22. For these many years that question repeated. Okay, and similar this year also it is mostly important. Okay, yes. So here in our example we have given from the record analysis of a correlation data. From the record analysis of a correlation data, the following results are available. Okay, yes. So variance of x, that means variance of x means sigma of x, which is equal to, that means standard deviation of x, which is equal to square root of variance of x. Okay, that variance of x given is a 9. Okay, and the line of a regression also given. Okay, the line of a regression given 8x minus 10y plus 66 0, 40x minus 18y, which is equal to 214. Okay, 214. After that we have to find out the value, find out the mean value of x and y. Okay, mean value of x and y means x bar and y bar, you have to find it out here. Okay, mean value of x and y. Then we want the standard deviation. Okay, standard deviation of y, that means sigma of y we want. Okay, and the third question we have here, coefficient of correlation between x and y. Okay, coefficient of correlation between x and y means you have to find out r of xy, and which can be written as covariance of xy divided by sigma x and sigma y. Okay, so let's get dive into the solution. Okay, so see that what we have given, using the given data try to build the solution. Okay, now see that variance of x is a 9. Okay, variance of x, it is a 9, and as we know that x bar and y bar be the mean of xy. Okay, so that means we have two number. Okay, let x and y be two series. Okay, okay, let me write here, let x comma y be two series, x and y be two series. We have given two series x and y. Then x bar and y bar. Okay, consider x bar and y bar are the mean. Okay, x and y having these two series having x bar comma y bar are the mean. Okay, both are the mean over here. Okay, so if we do not want that bracket. Okay, it look like order pair. Okay, x bar and y bar, x bar and y bar we have mean. Okay, for the series x we have x bar mean, for the series y we have y bar is the mean. Okay, why I have written this mean? Now see that we have given in our question. Okay, the record analysis of correlation data. Okay, that means whenever we have mean, it satisfies the equation. That means what we are looking here in our regression, the point which scattered. Okay, the point which scattered in a plane which lies on a same curve. Okay, which lies on a same curve. Okay, that means x bar and y bar, these are the two other points. Okay, two another points. Now till moment we are considering x bar and y bar are the mean. Okay, yes, but x bar and y bar, these are the 2 points which present in our given plane. Okay, x bar and y bar which is present in our given plane. So if that present in a given plane, so we have regression. Regression, it says that the whatever point we have in our plane, it should be lie on a same line or same curve. Okay, it should lie on a same line or same curve. That means x bar and y bar which lies on the curve. Okay, which lies on the curve. But which are these curves? So this one is the first curve, this one is the second curve. Okay, so if any point lies on the curve, that satisfy that equation. Okay, now see that x bar plus y bar which is equal to 2, okay, and x bar minus y bar which is equal to 2. So these are the two curves. For example, I am explaining, guys, okay, so how the points satisfy given curve, okay. Yes, now see that x bar plus y bar which is equal to 2 and x bar minus y bar which is equal to 2. Now see that in this case what we have, whenever we put the value for x bar we get the value for y bar, okay. That means this is some sort of equation of a line, okay, equation of a line. That means the point which coming on the equation of a line which satisfy this equation. That means if x bar is coming on the line, okay. So for example, if I consider x1 y1, okay, x bar 1 y bar 1, okay, here in this equation x bar 1 and y bar 1, okay. So if you going to replace x bar 1 and y bar 1 in this equation, you will get the 2 which is equal to 2. That means x bar and y bar, these 2 points satisfy this curve x bar plus y bar which is equal to 2, okay. Meaning for this that x bar and y bar which lie on the curve x bar plus y bar which is equal to 2. So if you want, you can plot the curve and check it out, 1 and 1 this point coming here or not, okay. Obviously 1 and 1 both will lie on that curve, okay. Yes, so similar meaning here, if x bar and y bar are the mean and which lies on this curve, that means this satisfy x bar and y bar satisfy both of these equation, okay. So we can replace the value for x bar and y bar, hence it satisfies our given equation, okay. 8 times x bar minus 10 times y bar, okay. How I am writing here, 8 times x bar minus 10 times y bar plus which is plus 66 which is equal to 0, plus 66 which is equal to 0, okay. And next 40 x bar minus 18 y bar, 40 x bar minus 18 y bar which equal to 214, okay. Now see that these two equation we got it here, okay, the value for x bar and y bar, okay. So how I have written, I hope you all have understood, okay, because see that the point x bar and y bar which lies on these two curves, that means these points satisfy these two curves, okay. If these satisfy these two curves, that means x bar and y bar obviously the solution for these two curves, okay, and solution can be replaced replaced to our curve, okay. That means 8 times x bar minus 10 times y bar 66 and 40 times x bar minus 80 times y bar 18 times y bar is equal to 214, okay. So what we have our first task, find out the mean value of x and y service, okay. We want the mean value means we want the value for x bar and we want the value for y bar, okay. These two value we want, okay. So if you want x bar and y bar, it is easier to find it out from here, okay. Yes, so what do? We solve these two equation, easily we'll get the x bar and y bar, okay. Now see that how can we solve this linear equation in a two variable. Now see that x bar and y bar, these are the linear equation in two variable, okay. So if you want to solve this one, multiply some element here and add subtract, okay. Yes, so this 40 times x bar is there and 8 times x bar is there. So what I'm going to I have to multiply over here so that we can cancel the denominator, and then we go for the subtraction. Easily we can cancel this term with this one, so it is easier to find out the value for y bar, okay. Yes, so what we do here, multiply 8 to the 5, okay, 8 to the 5 to this equation. So 40 times x bar you will get, and you can cancel with this one, okay. So multiply 5 here to this equation, 8 5s are 40 x bar minus 10 5s are 50 y bar which is equal to 66 5s are. So see guys, here I multiplied our given equation to the 5. I got this equation, minus 40 x bar minus 450 y bar minus 330, okay, which is equal to, and we have another equation 40 x bar minus 18 y bar which is equal to 114, okay. Keep them as it is, as we want to we have to cancel 40 x bar with that x bar, okay. That means we do not want that x bar. So if you want to cancel this one, so subtract both of them. So this one goes to 0, minus this minus gives us the plus, okay. That means minus 50 plus 18 into y bar, which is equal to minus 330 minus 240. So it is a minus 544. Okay, yes. So we want the value for y bar. So take this term to the other side, negative negative cancel. So y bar we will get the 17. Okay. So that y bar put here in one of the equation. If you are going to calculate the value, you will get the x bar is a 13. Okay. So I got the y bar and x bar. Y bar is 17, x bar is a 13. So this is the mean value of x and y. Okay. Mean value of x is x bar. Mean value of y is y bar. So I got the value of x bar and y bar over here. Okay. Yes. Now our next target is the standard deviation of y service. That means sigma of y. And next is the coefficient of correlation between x and y. Now we go for finding a regression of y in terms of x and x in terms of y. Okay, let's express. Okay, let me express over here. Okay, let's express. Okay, let's express given equation of a line. Okay, given equation of a line means we have the equation of a line 8x minus 10y plus 66, which is equal to 0, 40x minus 18y which is equal to 214. Okay, so let's express this given equation. Okay, let's express this given equation in the term of y in terms of x and x in terms of x y. Okay, yes, of regression y in terms of x, in terms of x, and x in terms of y. Okay, y in terms of x and x in terms of y. Okay, so using this equation, create the value for x and y. So using this equation of let's take first equation. Okay, using equation first, let's create the value for x over here. Okay, so 8x which is equal to minus 10y minus 66. Okay, 8x which is equal to minus 10y minus 66. So the value for x we write. Okay, the value for x, okay, 8x minus 10y plus 66 which is equal to 0. This one is the equation. Okay, so we write x which is equal to minus 10. Okay, so that plus it goes to minus here, and this one minus 10y become plus over here. Okay, so plus 10y. So plus 10 divided by 8 into y minus 66. Okay, by 8. See that what I have done, guys. The value of x I found here using the equation first. Okay, that we have to replace x in terms of y and y in terms of x. Okay, so that we have to find out the value for x using given equation. Okay, so 8x which is equal to 10y minus 66. Okay, 10y minus 66, and x which is equal to 10 by 8 into y minus 66 by 8. Okay, that 8 I took it outside. So using this way we go for the value of y also. Okay, so let's find out the value for y. This one is a. Another find out the value for y using our equation first. Okay, only we are working in our equation first. By using equation first, we are finding the value of x, and we go for finding the value of y now. Okay, so 8x plus 66 which is equal to 10y. Okay, so 10y can be written as 8x plus 66, and y can be written as 8 by 10 into x, 8 by 10 into x plus 66 by 10. Okay, see that I got the value for x over here. Okay, this one is the value for x we needed for regression x in y and y in x. Okay, this is the value for y. Okay, using equation 1 I found this one. Okay, let's go operate equation number 2 now. Okay, so using equation 2 I'm going to write the value for x and y. Okay, yes, so 40x can be written as 40x equal to 214 plus 18y. Okay, so we want the x, that means we write 214 divided by 40 plus 18 divided by 40y. Okay, This one is the value for x. I got it here using this equation. Okay, take this 40 over here, remaining term take it to the other side. So okay, I got the value for x over here. Okay, see that how easy it is, guys. Similarly, do it for the value of y. Okay, so y can be written as using second equation. We are working on second equation only. Okay, so using second equation, I'm going to write y, value of y. Okay, yes, so value of y, which is 18y. Okay, 18y which is equal to 40x minus 14. Okay, 40x minus 214. Okay, so what I have done, I taken 214, it negative here, it positive here. Okay, so y can be written as 40 by 18 x minus 214 by 18. Okay, see that I got the value for y over here, I got the value for x. Okay, so we got the value for x and y in our equation first, and x and y using our equation second. Okay, now we take combination of a line y on x with the other line x on y. Okay, yes, what we do, we take combination of a line y on x with the other line x on y. Now see that if let's bring x and y together, and that x and y together. Okay, so what we are doing basically here, we are taking combination of a line y on x with other line x on y. Okay, combination of a line y on x with other line x and y. Okay, yes, let me take the combination of a line y on x with other line x and y. Okay, take combination of a line y on x with other, take combination of a line y on x with other line x on y. Okay, other line x on y. Okay, take combination of a line y on x with other line x on y. Okay, yes, take the combination. So what we do, we select first y on x, then x on y. Okay, so 8 by 10x, let me take combination of line y which is equal to 8 by 10x. Okay, y which is equal to 8 by 10x plus 66 by 10. Okay, y on x, what is the value for x? X we have to take from another line. Okay, which is 18 by 40y. Okay, 18 by 40y plus 214 by 40. Okay, 214 by 40, y on x with other line x on y. Okay, so x on y, x we have for the other line means you have to take x on y. Okay, see that y on, this one is the y on x, we take another line x on y. Okay, take this x, take this y. So we are what we are doing here, we are merging the value for y on x and x on y here. Okay, x on y means 10 by 8y, okay, minus 66 by 8. Okay, 10 by 8y minus 66 by 8, y x on y. Okay, now we are taking x on y, and so y we can take here 40 by 18. Okay, 40 by 18x minus 214 by 18. I hope you all have understood how I have taken this combination, because see that we have regression of a line y on x and x on y, so that's why we are taking combination of y on x, okay, and x on y for finding the regression. Okay, yes, so see that we want the coefficient of regression. Okay, so we want the coefficient of regression using this equation. Okay, so let me write coefficient of regression. Okay, we want the coefficient of regression. See that coefficient of regression y on x, okay, we represent b of yx. Okay, see that coefficient of regression y on x is 8 by 10, which is the 8 by 10. Okay, coefficient of regression y on x is the 8 by 10. Okay, yes, and x on y is 18 by 40. So b of xy, which is equal to 18 by 40. Okay, so see that we have coefficient of regression y on x, we are taking 8 by 10. See that coefficient we want now for regression y on x, which is 8 by 10. Okay, and the coefficient of regression x on y 18 by 40. Okay, yes, so I selected this value b of xy and b of yx. Okay, yes, as we found here b of yx. Okay, so if you want the b of yx, so you have to select from here. So if you want the b of xy from beginning, then you select from here. Okay, yes, so I select b of y on x here, coefficient 8 by 10, and b of x on y, coefficient 18 by 40 over here. Okay, yes, so we know that, okay, we know that regression over line, okay, r square can be written as b of yx and b of xy. Okay, b of yx multiplied by b of xy, we take it is the r square. Okay, yes, so multiply this 8 by 10 multiplied by 18 by 40. Okay, so 8 by 10 multiplied by 18 by 40. Okay, so what I have done, I just taken their multiplication. Okay, so if you go for the calculation, further calculation, you will get the answer 0.3600. Okay, 0.3600. This is the value for r square, guys. Okay, this one is required r square. Okay, so it represents that r square is a 0.36. Okay, that means r gives us 6. Okay, that means we have r which is a bigger than 0. Okay, if r is a bigger than 0, then we consider the equation. Okay, which equation we have to consider? Okay, now see that as we have r greater than 0, that regression r greater than 0. So see that when we have r greater than 0, then we consider the equation star over here, okay, as the line of regression xy distribution. Okay, then star is line of regression, then star is the line of regression. Okay, for xy distribution. For xy distribution. Now see that, so let me explain one more time. Okay, see that our radius, it's a regression, we have 0.36, it is a positive. Okay, that means r, it is bigger than 0. That means if you're going to take square root, obviously you will get the 0.6. Okay, so this one is bigger than 0, r it is bigger than 0. That means we take a line of a regression. See that this one is positive, this one is positive, then whatever the value you're going to select over here, answer you will get the positive. But as we have negative over here, so maybe you will get the negative answer. Okay, maybe possible chances that this line can give us the negative values. Okay, but these lines never gives us the negative. Okay, this always gives us the value positive. Okay, this always gives us the value positive. Okay, maybe there is a possible chances that can give us the value negative. Okay, okay, may be negative. Okay, may be negative. Yes, so this one is maybe negative, this one is a certainly positive. So we take this line, okay, this star as a line of a regression for xy distribution. Okay, so I'm taking this one here. So as I received here, r square is equal to 0.3600. Okay, so if you are going to take a regression, you will get the square root for the both sides, square from both sides, we get the 0.6. Okay, yes, but as this one gives us the plus 0.6 and this one gives us the minus 0.6. Okay, okay, this one gives, r gives us the plus 0.6 answer and minus 0.6, but minus 0.6 never possible. Why never possible? Because we have this regression completely positive, there is no negative value possible over here from this regression. Okay, so that's why I consider plus 0.6 as a r. Okay, so r which is equal to plus 0.6. Okay, so I received here r which is equal to plus 0.6. because of that their coefficient for regression, it is a positive over here. Okay, yes, so r which is equal to 0.6 I consider. Okay, r is equal to 0.6, it is a positive, so that we write r as a correlation coefficient between x and y. Okay, this one is the correlation coefficient between x and y. Okay, this we write correlation coefficient between x and y. Okay, yes. So now see that we got the correlation coefficient between x and y are as 0.6. This one is our next part for the question. Okay, coefficient for correlation between x and y. Okay, so we want the standard deviation of y. Okay, that means we want the sigma y. Okay, so what is our next target? To find out the sigma y. Okay, standard deviation with respect to y. Okay, so we know that b of yx can be written as regression of xy. Okay, regression over xy multiplied by sigma y divided by sigma x. Okay, yes. So just replace the value. Okay, so b of y over x. Okay, regression y over x. What we have the value? B of y over x. Y over x is 8 by 10. Okay, b of y over x is 8 by 10. So replace the value over here. 8 by 10. Okay, regression is a 0.6. 0.6. Okay, yes, regression is we have here 0.6. And sigma y we want. Okay, we want the sigma y. So what about for sigma x? Okay, how can we find the sigma x? As we have given in our question, what we have given in our question, the record analysis of the correlation data for the following result available. Variance is a x. Variance for x is a 9. Okay, variance for x is a 9 given. Okay, so we have given variance for x is a 9. Okay, that means sigma x, which is equal to variance of x. Sigma x, sigma can be written as square root of variance. Okay, but if sigma standard deviation over x, we write a variance of x over here. Okay, and variance of x we know that it is a 9, so it is a square root of a 9. Okay, sigma x, it is a square root of a 9. Okay, and then we can write sigma x as a 3. Okay, so we have standard deviation over x is a 3. Okay, standard deviation over x is a 3 here. Okay, so replace this value over here. Okay, and find out the value for sigma of y. Okay, yes. So 8 take here, we get the 8 3s are 24. Okay, 0.6 to the denominator we take 6. Okay, okay, then 6 1s are 6, 6 4s are 24. So we got this standard deviation over y as a 4. Okay, okay, this one is our required answer. Okay, we want the standard deviation over y. Okay, now see that in our question what we want, find out the mean value for x and y service. Okay, so see that I found the x bar and y bar at the beginning over here. Okay, first question answer I got it here. Then we want the standard deviation of y service, that means sigma of y. So recently we found here sigma of y here. Okay, we have found here sigma of y. Okay, now next what we want in our question, coefficient of correlation between x and y service. Okay, so we want the coefficient of correlation between x and y, so we write coefficient of correlation between x and y as a r. Okay, r of xy, so which is a 0.6. So see that guys, I found all the answer over here. This one is a very much important question, asked plenty of the time in your question paper. Okay, take note of this. So if you want, you can take this example, write down, note it down in your notebook. Take it for your preparation. I am just slowly sliding down here. Okay, see that this is the entire answer. Okay, so we go for the next page over here. Okay, in our next page, it is here. Okay, then go down here, you will get the value, entire value over here. Okay, yes, that is here for my today's lecture guys. I hope you all have understood everything here in my today's lecture. Even after, if you found anything difficult, confusing, or if you do not understand anything guys, let me know in my comment section. I will come up with the similar videos. So thank you everyone, thank you for my today's lecture.